You know how you can give a chatbot a quick question, but you can't just hand it a whole novel? Ever wonder why? Well, it looks like some researchers have cracked a huge piece of that puzzle by, get this, teaching AI to read in a totally different way. So let's dive into this wild new idea they're calling optical compression.
I mean, it sounds so simple, doesn't it? We read long books, articles, whatever, all the time. But for a large language model, an LLM, trying to process a really long text is one of the biggest hurdles out there. To really get why, we've got to understand how an AI sees words in the first place.
Okay, so the real heart of the issue, it's something called the expensive memory problem. And it's a huge bottleneck. It's basically what limits how much stuff an AI can keep in its, let's call it short-term memory at any one time.
You see, an AI doesn't read words the same way you and I do. It chops everything up into these little pieces called tokens. Now, a token could be a whole word, maybe like apple, or it could just be a piece of a word, like the ing in running. Think of them as the basic building blocks, the Legos of language for an AI.
Okay, so here's where things get tricky. A nice, short sentence? That's just a handful of tokens, no big deal. But a single page from a book? Whoa, that just explodes into thousands of tokens. And you can probably guess what that means. The more tokens you throw at an AI, the harder its circuits have to work.
And this is the absolute kicker. The cost, the amount of computer power needed, it doesn't just go up in a straight line. It goes up exponentially. The fancy term for this is quadratic scaling. And honestly, it's the main villain of this whole story. It means if you double the amount of text, you don't just double the cost, you square it. That's what makes processing an entire book so ridiculously expensive and slow.
Okay, so if feeding an AI a mountain of text tokens is the problem, what's the solution? Well, this is where it gets really cool. Researchers over at DeepSeek AI had this, honestly, it's a brilliant, kind of weird idea. They thought, what if we just stop trying to make the AI read text? What if instead we just showed it a picture of the text?
Yeah, you heard that right. This is a total paradigm shift. The core idea is you take a whole page of text with all those thousands of text tokens we talked about, and you just turn it into a picture, a single image. Then, the AI breaks down that image into a much smaller number of what they call vision tokens. It really is like turning a giant, dense library into a much simpler comic book.
And the crazy part? It actually works, like really well. The researchers plotted it all out. They looked at how much they compressed the text image versus how accurate the AI was. And what they found was wild. Even as you squish that image down more and more using way fewer vision tokens, the accuracy just stays incredibly high. So just how high are we talking? Get this, even when they compressed the original text by a factor of 10, so think about turning 10,000 text tokens into just 1,000 vision tokens, the model could still rebuild the original text with about 97% accuracy. That's just incredible.
So this isn't just some wild theory on a whiteboard, right? This is a real working technology. And the hero of our story, the model that actually pulls all this off, is called DeepSeek OCR.
So how does this thing actually work? Well, at its core, DeepSeek OCR is really made of two main parts. It's helpful to think of it as having a super smart eye, that's the DeepEncoder, and its job is to look at the picture of the text and compress it down. Then you've got the powerful brain, that's the decoder, which takes that squished down info and actually understands it, turning it back into text.
And that eye, the DeepEncoder, that's really the secret sauce here. It's got this really clever three-step process. First, it looks at the details, focusing on little windows of the image. Then, and this is key, it intelligently compresses what it sees, shrinking it down by a factor of 16. And finally, it pulls out only the most important bits of knowledge from that compressed version before handing it off to the brain. That whole process is what makes it just so ridiculously efficient.
But look, talk is cheap, right? The proof is always in the performance. So how does DeepSeek OCR actually stack up against the other big players out there? Let's check out the results. So when you look at a standard benchmark chart like this one, the place you want to be is in that bottom left corner. That's the sweet spot. Super accurate, but also super efficient. And as you can see, the different versions of DeepSeek OCR are just dominating that corner. They're getting top-tier results while using way fewer tokens than the competition.
And this table here, wow, it makes the difference crystal clear. Take a look at a competitor, Miner-U, which is a really strong model, by the way. It needs almost 7,000 vision tokens to process one page. Now look at DeepSeek OCR. It gets even better results using less than 800. That's almost a 90% drop in cost for better performance. It's just a huge leap.
So, what does all this really mean? What's the big picture here? Well, this is way bigger than just making an AI that's better at reading PDFs. This kind of breakthrough could fundamentally change how we design AI systems, and especially how they remember things.
There's this quote from the paper that I just love because it connects all this high-tech stuff back to something we can all understand, our own brains. The idea is that by compressing older info into smaller, fuzzier images, the AI's memory starts to act like ours. You know how recent memories are super sharp, but stuff from years ago is kind of hazy? It's like that. It's a much more natural, almost biological way for an AI to handle memory and, well, to forget.
And when you start thinking about what you can do with this, wow, it gets exciting. I mean, imagine a chatbot that actually remembers your entire conversation history, not just the last couple of things you said, or an AI that could just tear through massive archives of legal or medical documents at lightning speed. You could even have AIs that can skim a document to get the gist, just like we do, before deciding if it needs a closer look. This is a total game changer.
So, in the end, by teaching an AI to see text as pictures, this research isn't just solving a technical memory problem. It's really giving AI a more intuitive, more human-like way of processing the world. And that leaves us with a pretty fascinating question to chew on, doesn't it? If an AI's memory starts to work more like our own, what will it dream of?